So I'd like to welcome you all to the first of three lectures on cosmology by Professor Mike Turner. My name is Mark Whittle and I'm currently chair of the Page-Barbour and Richard Lecture Committee. And so before I introduce Professor Turner, it's customary and appropriate to say a few words about these two lecture series, which are the most prestigious lecture series in the University's College of Arts and Sciences. So the James W. Richard Lectures were established in 1923 by an endowment from Mrs. Esther Coffinbury in honour of James W. Richard to support a series of lectures in religion and history. Past speakers have included the notable scholars Paul Tillich, Paul Ricoeur, John Hick, Quentin Skinner, and more recently, Jean-Yves Lacoste. Looking forward, next month, the 2012 Richard Lectures will be given by the great Princeton historian of religion, Peter Brown, and beyond that, the renowned Buddhist scholar, Robert Buswell. He'll give the 2013 Richard Lectures. And turning to the closely related and equally prestigious Page-Barbour Lecture Series, this was established in 1907 by a gift from Florence Lathrop of the Barbour family of Barbourville, in honour of her husband, Thomas Page, who graduated from UVA's law school in 1874 and ultimately went on to become US Ambassador to Italy under the presidency of Woodrow Wilson. Mrs. Page's gift specified that the Page-Barbour Lectures could be in any field within the arts and sciences and were intended to present, quote, some fresh aspect of the department of thought in which the lecturer is specialist. So past Page-Barbour lecturers include no less than the President and Chief Justice William Howard Taft, the poets T.S. Eliot and W.H. Auden, philosophers Alfred North Whitehead and John Dewey, psychologists B.F. Skinner and Robert Coles, physicists Robert Millikan and C.N. Yang, and astronomers Henry Norris Russell and Fred Hoyle. Looking forward, our next Page-Barbour speaker will be the influential British literary theorist and critic Terry Eagleton. Now, if you wish to revisit any past lectures, most have appeared as books published by the University of Virginia Press, and indeed our hope is that this week's lectures will also appear in book form and make a significant addition to an already well-known and prestigious series of monographs. Now, it's at this point that I take off my hat as chairman of the PBR committee and put on my hat as Professor of Astronomy and say a few words of introduction for our 2012 Page-Barbour speaker, Professor Mike Turner. Professor Turner is currently the Bruce V. and Diana M. Rauner Distinguished Service Professor and Director of the Kavli Institute for Cosmological Physics at the University of Chicago, where he's been on faculty since 1980. Professor Turner has made many enduring contributions to astrophysics and cosmology, and I will only mention a few. Perhaps most of all, Professor Turner's, Professor Turner is known as one of the founding members of a highly productive research group at Chicago, which in the early 1980s began to explore the connections between particle physics and cosmology, the fact that conditions in the early universe were similar to the kinds of conditions explored by the high-energy physics community with their particle accelerators. Indeed, he and colleague Rocky Kolb co-authored what was, and still is, a definitive text on the subject called simply The Early Universe. That group thrived and grew and is now the Fermilab Center for Astrophysics. And I'm hoping we'll hear a little more about this time from Physics Professor Hank Thacker in his introduction tomorrow, since Hank was at Fermilab during that time. Professor Turner's name is also closely associated with the relatively newly recognized and major cosmic component, dark energy. Indeed, Mike not only coined the term dark energy, but with Lawrence Krauss, he even predicted its existence in 1995, 3 years before the startling results of the high redshift supernova studies, which showed strong observational evidence for its existence. And since then, Mike has played a key role in defining how the next generation of studies will try to establish the true nature of dark energy. In the early 1980s, Mike was one of the first, with Bardeen and Steinhardt, to show how quantum fluctuations present during the universe's brief creation and launching period, a period called inflation, could generate the slight lumpiness that is necessary to ultimately make stars and galaxies. There is a lovely account of this work that has, and that exciting period, in Alan Guth's popular book, The Inflationary Universe, if you want to look at it. Now, as my final example, following earlier work on Big Bang nucleosynthesis, now that's the physics of fusion reactions that occurred only a minute after the Big Bang, Mike worked with colleagues Dave Schramm and Gary Steigman to make detailed calculations of the yields of the light elements hydrogen, helium, and lithium. And this in turn led to a robust estimate of the total atomic content of the universe, as well as showing that there were 3, and only 3, species of neutrinos in nature. Mike's research has led to many prizes and awards, of which just a few are the Warner Prize of the American Astronomical Society, the Lilienfeld Prize of the American Physical Society, election to the National Academy of Sciences, and the Heinemann Prize of the AS and AIP. In addition to his scientific research, Professor Turner has also played a major role in what one might call scientific governance. Again, citing just a few examples, he was chair of the National Research Council Committee on the Physics of the Universe, which published in 2003 a very influential volume entitled Quarks to Cosmos, which identified 11 key questions that have helped define the priorities for astrophysical research in the last decade. From 2003 to 2006, he was Assistant Director for the Mathematical and Physical Sciences at the National Science Foundation. And in this position, he oversaw a budget of $1.1 billion across 5 divisions: astronomy, chemistry, materials, mathematics, and physics. And that led to the planning of, among other things, ALMA, the Atacama Large Millimeter Array, which I know many of you in the audience are deeply involved with. He is currently chair of the American Physical Society. He's been chair of the physics section of the National Academy of Sciences and president of the Aspen Center for Physics, and the list of leadership positions could continue for quite a while. But I'll stop here and hope that if you were not already familiar with Professor Turner's career, you now know him to be a person of great stature, not only as one who has contributed substantially to the body of knowledge of physics, astrophysics, and cosmology, but also someone who's devoted much time and energy to the stewardship of those subjects in what is a complex economic and political world. We're both privileged and delighted to have him here this week to give the 3 Page-Barbour lectures on one of the most interesting and extraordinary subjects in modern science, nothing less than the origin and evolution of the entire universe. His 3 lectures are today, tomorrow, and Thursday, and they're all here in this room, and they're all at 4 o'clock. And I'd also like to add that after each lecture, there'll be time for questions, and following that, you are warmly invited to continue the conversation at a reception in the foyer. The overall title of Professor Turner's lecture series is, you can probably see it up there, Cosmology, From the Birth of the Universe Until the End of Time. And his first lecture is called The Simple Universe, from Einstein and Hubble to Penzias and Wilson. Please join me in welcoming Professor Mike Turner.